So today we're talking about covalent bonding and structural formulas, which when I say something like structural formulas, you might think it's going to get harder. Structural formulas are actually going to make our lives easier, so we have to worry about less electrons. Let's do a quick review of ionic bonding. Why did atoms bond ionically? Well, because they were unstable. Why were they unstable? They had the wrong number of electrons in their outermost shell, in their valence shell. And so one atom would give away an electron to another atom, and this would cause the atoms to change charge. And when they would change charge, they would stick together kind of like a magnet of different poles, okay? So ions are incredibly important in biology. Don't forget about ions. We're gonna, you're going to see them. However, the molecules that make up living things, that hold living things together, are covalent bonds. You are made of mostly covalent bonds. Your genes are made of covalent bonds. You inhale covalent bonds. Your muscles, skin, your tissues, your organs are made out of things that are mostly covalently bonded. What is a covalent bond? The term ionic implies ion, which means there is a change in charge, whereas covalent implies that they are sharing a valent bond, or they're sharing an electron in their outermost shell. Let's look at H2, which is the most common element around. It's also the simplest element around. If we look at hydrogen by itself, if you look at the periodic table, you'll see that it has one proton, and so a neutral atom of hydrogen has one electron. Hydrogen has this one electron in its outermost shell. It's going to wind up sharing it with another hydrogen. You can see here that each of these hydrogens has its one electron, but if they share them, they feel like they have two in their outermost shell. And in fact, they do have two in their outermost shell. So H by itself, hydrogen by itself, unstable. H2, quite stable. They're sharing this electron. This is a covalent bond. Let's look at another incredibly common compound or molecule. Let's look at CH4. CH4 is methane gas. It's important for fuel. If you are using natural gas, you're probably using CH4 or a CH4 derivative. It's an incredibly important molecule when it comes to climate change. And so let's look at the orbital configuration of carbon. It has those 4 electrons in its outermost shell. And what it's going to do, it's going to wind up sharing them with hydrogens, making them all stable. And so you can see here, this carbon has all of these bonds, and those bonds are what's going to make it feel like, and actually it's going to make it so that it has 8 electrons in its valence shell. So let's do another very important molecule. Let's do C2H6. That's ethane. And go ahead and pause the video and see if you can figure out what the formula for C2H6 is. Let's go ahead and introduce what's called structural formulas. We've seen these orbital arrangements. Structural formulas are actually much simpler, and all we're worried about with the structural formula is the bonds, which are represented by a dash. So this dash shows that two different elements are sharing a pair of electrons. And so this in CH4, carbon has 4 dashes. Each dash represents 2 electrons. And so you can see 2, 4, 6, 8. Carbon has a filled valence shell. If we look at hydrogen, well, hydrogen just has 1 dash connected to it, right? But hydrogen is still happy because remember, the first valence shell, the first orbital, only has 2 electrons in it. And so hydrogen has a filled outer shell from this 1 dash, okay? And so maybe you hopefully can see structural formulas are easier to think about than those orbital models. You have to do less accounting for electrons, and they're a little bit simpler to look at. But you need the orbital model to really understand what's happening. But let's keep going. Let's try another molecule. Let's try ethane, which is C2H6, 2 carbons and 6 hydrogens. And so here is the orbital model, and here's the structural model. And if you count up all of the electrons, you can see that all of these atoms have filled outer shells. This ethane molecule makes everything more stable. Thus far, we have talked about covalent bonding, where two atoms are sharing an electron, so that electron counts for each of them. We have looked at structural models where dashes represent these covalent bonds. I'd also like you to know there are double covalent bonds. Two atoms can share two pairs of electrons. Let's try
C2H4,
which
ethylene.
So
ethylene
is really important. It's important for polymers like plastics. It's also really important in the development of fruits. So if you ever listen to your grandmother's advice and you have an underripe avocado and you put a banana next to it, the banana is going to wind up releasing this ethylene molecule, which will cause not only the banana to ripen, but it'll cause the avocado to ripen as well. But let's look at this. You're going to need some double bonds. See if you can draw it. Pause the video. See if you can figure out how this arrangement's going to work. And we'll put it up right here. And you can see this double bond between these carbons. So they're sharing two pairs of electrons. So this carbon on the left has 2,4 electrons in its outer shell, 6,8 with those other two hydrogens. Oxygen also has a double bond, and you can see triple bonding happen as well. I won't say they're less important. We won't see them as often, but if you see 3 dashes, that is 3 pairs of electrons being shared. So like I said at the beginning, covalent bonds are what hold life together. You are made up of mostly covalent bonds. So what is the purpose of a covalent bond? Why do atoms bond covalently? And that's to make themselves more stable. It's so that they get into a more stable form. It's the same, like, why do they form these bonds? It's the same reason that like a ball rolls down a hill. It's trying to become more stable. Okay, next time we're going to talk about water. We're going to talk about another type of bond. Hopefully we'll be done with all this bonding soon. But we're going to talk about water and why water is so special and important to life.